Yep. So, hello, Bulgaria. I'm super happy to talk about, to be talking here. One of the reasons this presentation is going to be about the past. And this is the homeland of this person, who is my childhood hero. Does everybody know who is this guy? Before someone talk about Bulgarian soccer, so in Barcelona we know a lot about Bulgarian soccer. But actually there's another reason, not soccer related, why I'm happy to talk here. And it's about this novel by Georgy Gospodinov. It's called Time Shelter. And I recommend you to read, but the general idea is that people doesn't want to live in the present. They would prefer to live in an imaginary past and close themselves there. This is a bit the topic of my presentation in a certain way. Okay, so let's start with the general ideas. This conversation is going to be about time. And it's about time also because it's a moment in my life that I thought that I felt like thinking about what happened to me in the last 10 years. I recently moved back to Barcelona. I've been 10 years abroad, mainly in Denmark and the US. I also made 10 years working at Zendesk. And even probably you don't know about this TV show, but I started watching this show called Frieren. Probably, I don't know if you like anime, but this is very interesting. It's actually, I think, well, I would say it's the greatest anime show ever. Just for you to get the idea, it's about magic, and there is a great tradition of shows about magic to talk about technology. You can take a lot of them, like, I don't know, like the Wizard of Earthsea, for example, is for me, I always read it as a metaphor about object-oriented programming, because the concept of a word is what makes the magic. Frieren also continues this tradition, but here the main point is time. You see, you have this elf who is immortal, has lived over 1,000 years, and has seen the evolution of magic. It's like, you see like new frameworks, like literally this is a spell that 50 years ago was incredibly strange, and now everybody knows it, you know? You see the evolution of it. It's a great metaphor, in my opinion. Moreover, for me, I think it was natural to like this show because I identified with it, with her in particular. She's an elf that has lived over 1,000 years. She's strange, you know? She's the possessor of forgotten, forbidden magical knowledge. And I'm sorry, I think that I am equally mythical. I've worked in the same company as an engineer for 10 years, which is incredibly strange in our sector. And this also makes me the possessor of forgotten, forbidden magical Rails knowledge. This presentation is about sharing it. One part I want to talk about is about the monolith. You know, we discussed a lot about the monolith. I started working with Ruby around 15 years ago. This picture is from 2010. And 2010 was a weird time, you know, like we used to like Eminem at that time. And one thing that we used to like in those times were also monoliths. And I think I'm happy because I see that monoliths are back. At least the Twitter engineering is way more happy with the idea of a monolith. But 5 years ago, if you say, "Oh, I'm going to do a startup, I'm going to use a monolithic architecture," you were like an idiot. It didn't make any sense. Nobody liked that. I am chill about this because I think that a lot of concepts in software engineering are like a pendulum. If you've seen, for example, with this, monoliths were incredibly mainstream 15 years ago. Then everything needed to be distributed. Now we are somewhere in the middle. With this, I don't mean that opinions doesn't matter. This is a dangerous pendulum. You can get hurt. If you decide, oh, my startup that doesn't have fit to market is going to start with 20 microservices, it's going to be hard for you to iterate. But I have even more spicy opinions than that. Sometimes I believe that the microservice boom is a little bit of a zero interest rate phenomena. Like, reality is that in the last 5 years, the companies had a lot of money, and I think some of them fell in the hole of premature optimization. You know, like, oh, we don't have millions of users yet, so we are going to create this very complex architecture, and then we will be fine in the future. That is true, you will be fine in the future, but the future won't arrive. Actually, I literally met a friend of mine in Montreal. He joined a startup, and he literally told me that we have more microservices than customers. I mean, I am not a radical here. Microservice architectures have a place in tech. I don't think like Elon Musk, even if I think that this is hilarious and it's very punk. My opinion is more similar to the GitHub CTO, Jason Warner. I think that there is a spectrum, there is a gradient, you know, and you should move slowly to the other side of the gradient. If you start a company, you are probably safer with a monolith, and then slowly as it grows, go to the service route. Okay, and how does this apply to Zendesk? We started with a very simple vision, like our CEO wrote a Rails 1 application. And then as we grew, he decided, oh, let's make a smaller Rails applications for different things that we want to do. But those applications will share logic. So at Zendesk, this is a real snapshot from our gem file. We have a lot of internal private gems that are shared by a few of our older applications. Then later we moved to what I call the service era. This happened because we started acquiring other products, and we wanted to integrate them. For example, we wanted all of them to share accounts. And we didn't want our Rails monolith to be the account service or the user service. So at this point, we started writing new applications in different technologies. Yeah, this was triggered again by us entering new domains. And nowadays, we went more to event-driven architecture. We have an application that generates events that are Kafka messages that are consumed by other applications, and it's like a pinball game based on what is happening in the system. In the future, for the monolith, I think we are going more to go back a bit to the idea of modules, of strictly, strict modules that don't touch each other except in very specific spaces. We are actually starting to integrate backward in the monolith. But before moving forward on this section, I would like to talk a little bit about the front end, even if this is a Ruby conference. Let's go back to the 2010s, to an era that anybody that was writing web applications, I think some have a little bit of PTSD. Do you remember the great JavaScript wars of those times? When you opened Hacker News and there were like 5 new frameworks, and wars, they all got a lot of traction. You need to learn a new framework per week. I mean, this was a thing at Zendesk. Like we had, in big applications, we used Backbone, Ember, and React at different points in time. We all had to rewrite things very often. I am pretty sure that somewhere we use Angular. I couldn't find it. We even got to a point that we have something called Car.js. Nobody knows Car.js here, no? Good. So actually, that's not even the official name. We call it like this in the company because someone called Cart, we don't know the surname, but nobody remembers, wrote an internal framework. And it's hard to understand the code. So actually, Cart, if you're here, please contact us. No, but this shows that at a certain point, everybody wanted to write frameworks, and we had a lot of complexity there. I think that's, that when the JavaScript scene kind of standardized at a certain point into React, that made life way easier for developers. Sometimes I think I like React, but sometimes I think that one of the triggers for this standardization was that people got a little bit tired of having to change and learn so many different frameworks. And now that I've talked a little bit about these frameworks, I wanted to talk about which kind of technology we have at Zendesk. Of course, we have this huge Ruby monolith, and this has been like this since 17 years. And all those times, it was very easy to add like a new technology to the stack. You just created a new application in whatever technology, deployed, and that was it. The thing is that was foolish. In a big organization, you cannot. It would be great, but you cannot allow everyone to add, hey, I'm going to add a new language, a new storage. It just doesn't scale. So we created what we call the tech menu. The tech menu is that we have a set of approved technologies that can be used. And if you want to add a new one, you need to make a proposal, and the architectural team will approve or not. With this, this generated great discussions in the company. For example, I remember 7 years ago, we needed to decide which language we were going to use for writing services. I was Team Elixir, and we lost. I would love to say that we used Elixir, but we didn't use it that much. And interestingly, most of the company was divided into 2 options. One was Java, and the other was Scala. Eventually, this was this kind of Solomon decision, and we accepted both. And different parts of the company started creating services with them. I can tell you that as 2024, Java is way more common. We had issues hiring Scala developers or even onboarding new engineers into Scala. But actually, the most common way for us to adopt a new technology is via acquisition. You can say, hey, in this company, we only write Ruby. But if you want to buy a company that's using Python, that's it. You have Python in the company. Most of, actually, these are products that we use, that we have at Zendesk. Around half of them are a product of an acquisition. As an example, I would like to talk about the first one, that was Zopim. This is a chat company based in Singapore. And as I told, they were a Python company, so we have Python. But one thing I want to talk about when you acquire a company is not so much like the new technologies that they're bringing to the team, but about what I call the domain fusion. We, at Zendesk, we are a customer support company. Customers create tickets to communicate with the company that they bought something with. Zopim is a chat company, completely different domains in a way. But of course, we bought Zopim with the idea of, hey, the tickets right now will be able to be a conversation. How do you fuse these completely different domain models? The person that wrote Zopim 15 years ago was not thinking that this is going to be a ticketing company. You need to assimilate it. You need to make from two very different things to make one. Here, again, these concepts of ticket, chat, conversation. What is what, no? This starts as a product problem, but becomes very, very fast a technical one, obviously. In the end, after 10 years working with these problems and with other ones, like, for example, now in customer support, there is a lot of AI. Is a AI interaction of 20 seconds a chat? It's a bit hard. So what we realized is that we needed a lot of different objects to share the same features. And because of the past, again, the past is very heavy in tech companies, what we defined is that everything is a ticket. This is very highly debated in the company. We're always, with the architectural team, we're always discussing it, but it's the reality as right now. The ticket of it is like Barbie. No? You have the Barbie astronaut, Barbie president. Ticket is the same at Zendesk. Can be a chat, can be a bot conversation, can be a phone call. So again, you need to make of very different things the same just for product purposes. And now Anatoly will talk about the database.
Hi everybody, my name is Anatoly. I'll be talking about database performance at Zendesk. Zendesk today is 2,000 engineers, 6,000 total people. So what we have today is a large data set. So the larger the system, greater amount of data you will store in your database. How many of you have large data set in your databases? Okay, how many of you think that you will have large data set in your database? I think everybody will. I think everybody will. This is very important. And why is it important? Because your application performance depends on your database performance. Zendesk transitioned from data center to the cloud, I think like 7-8 years ago. What happened is databases became the biggest bottleneck. So we did not anticipate how difficult is it to be in the cloud, like in a public cloud environment. And let me go back to the, does anybody know this book, High Performance MySQL book? Okay, all right, cool. So this is my first book. When I started to work on database performance issues on Zendesk 7 years ago, I read a few chapters of this book, and first chapter was just mind-blowing. So authors of this book go through a very deep troubleshooting session, how they fix one query. And why fixing a query is important is if you experience some problems with the database and which translate to application performance problem, you don't go to look at the whole server, you look at one server or at one query. This is a very important concept which will explain my next 10 slides. Fast query is not a coincidence. It takes so much time and effort for database query to be very fast. And one little thing can ruin it all. It takes so much energy for your application to rely on the database and be performant and fast all the time. On the other side, performant database is not a coincidence. So it also takes a lot of time to find the queries you will write, you will run on the database, and some queries you will not run on the database. Cristian asked me to take a few photos for a few funny pictures, and I found, I don't have any funny pictures, but I have Lev Tolstoy, Anna Karenina, if anybody knows this book. And I think that's a perfect fit to what we have at Zendesk. It's just ideal fit, okay? All unhappy families are alike. Each unhappy family is unlike in some way. The same happened to the database. Each happy query, all happy queries are alike. Each unhappy query is unhappy in its own way. No, I tried to make some joke about it. I probably couldn't. Okay. When you have too much data in your database, you have to know, well, I'd like to share what we learned at Zendesk. when you have too much data, and we have data which actually grows exponentially very fast, your database server is very slow. You can do nothing about it. Just take it, and your life will be much easier. So don't believe that your cloud provider, like any provider, can make it fast. No, it's very slow. It was slow. It will be slow. It can't tolerate a large data set. I know it's probably shocking, right? Because the database has to feed data you need. Well, if you think about it, that this message will give you like extra life, like extra years to your life. And the third thing is you can't mix analytical and transactional queries at the same time. Analytical queries select count from table of 50 million rows. So some analytical long-running queries can actually kill the performance while you run your transactional query pattern. And why is that? Well, this is 17, I know. Anybody can read it? No, I can't read it. Okay, it's 17,000 lines of code of the query planner in MySQL. I think it's MySQL 5.7. Any little thing can go wrong. You have indexes in your tables. Database missed this thread index and a query go wrong. You have a query which was fast before, not anymore because you have too much data. And every little thing can go wrong, and your application becomes very slow. So it's very important concept that the application performance of the large system depends on the database. Three things happen at Zendesk. This is the past. Small data set. You just ignore this part. So we expected performant runtime, and we could run any query we wanted, absolutely anything. We didn't have to worry about this part. So from three circles, you can pick two, and we were there. We pick exactly these two. Around 5 years ago, what happened? Data set is no longer small. Data set becomes too large. I wish I have some funny picture there, which I have to learn from Cristian or from other speakers. Data set becomes too large, and query time had to take a back seat. But the future is different. The future is no complex query whatsoever. And you can ask me how we can have not query, like how we can eliminate all complex long-running queries. What we have to do to that? Well, if you take Pareto principle, I can say three things. The application you have doesn't need all your queries. So for majority of API endpoints you care the most, you need 20% of the queries to be fast. If database is overloaded and too heavy, the reason for that is 20% of the queries. And if you're cost conscious and aware that you don't have to improve everything, you have to improve only 20% of the queries. And this is the message which I would love to leave you with. Database performance is hard, but if you don't look at all queries to be fixed and performant, but some small part, you'll be where you want to be. After Cristian.
Yeah. So I would like to comment on two other things. The first one is testing and reliability. How do we maintain such a large Rails application reliable? Well, one of the big ideas of the Ruby community is that we don't need types, and the idea also is that because we have tests. Again, this idea is very important for us because, again, we are not using sorbet or anything like this, and we have a very large application. More or less, I counted that in the monolith itself, not counting all those private gems that I was talking before, it's around 1.6 million lines of code. Moreover, of course, you will thinking, you will need a lot of tests here. I counted them the other day, and we have around 55,786 unit tests. That's not counting features and browser API tests. But I would say the real secret sauce that we have at Zendesk is one specific person. I don't like to talk about specific people here, but I think he's great. He's our Cerberus of he's the Cerberus of Zendesk. He's like the protector of the main branch. He's famous because he won't really let you merge something he doesn't like it. I mean, that's his avatar, literally in Slack. It's Ryan Davis. Maybe some of you know him as the creator of maintainer of Minitest. And next comes one question that a lot of the new employees at Zendesk made to me. Why Minitest? Why are you using Minitest and not RSpec that is somehow a little bit more popular, seems like? Well, the reason is that we have a lot of tests, as before I was commenting, and actually in each PR we run them twice. I will talk later about that. This means that we're running 111,572 tests with each PR. Okay, so Minitest happens to be smaller, less magic, and especially way faster than RSpec. That helps a lot. Actually, in our version of Minitest, I would say it's kind of Minitest minus minus, the opposite of C++. So because we try to remove features and use the bare basics of it, so we can get performance. Still, we have pain points in the test suite. Which are they? Well, flaky tests. You know, this kind of test that passes 99% of the time and 1% doesn't, and you get a red build. Those ones hurt a lot. Just to give you an idea, this is how our GitHub Actions looks. We have all the tests grouped in groups of around 1,000 tests, and then they execute. The problem is that if one of those tests breaks, we need to run the whole check. So this means around 2,000 tests that you need to run just because one broke. And this is now we're in good times. Before, I don't know if you use GitHub Actions, but before GitHub Actions didn't allow you to run one check. If one test broke, that means that we had to rerun 111,000 tests. And you had the risk that there was another flaky test somewhere, and again, and again, and again. So thank you, GitHub, for implementing running only one. Still, I would say the most important thing that we have about how we keep them reliable is this: ownership. Ownership of the code. Again, we have a lot of code, and we have a lot of people that wrote that code. Historically, there is 2,459 committers in the monolith. And of course, you are thinking, well, this monolith has been around 17 years. Maybe there's not that many today. In the last year only, there was 570 people, different people that wrote code in that monolith. So a lot. I mean, and if we wouldn't have a good organization, it would be a battle. It would be impossible. What we use, and it works for us, is very strict ownership. We use the code owners feature in GitHub. This is like an example how it would work, with teams assigned to each file. Nowadays, we don't allow you to create a new file, even a test, if the file doesn't have an owner. Next, and this is the last part, is upgrading Rails. Zendesk has been around for a while. We started in Rails 1. And the best tool that we have for upgrading Rails historically has been also tests. You remember that before I told you that we ran all the tests twice? Well, because we ran them for Rails.current, that is the version that we are currently running, and for jamefile.next, that is the version that we want to move on. Of course, we accept that if we are just starting the upgrade, the build will be red, but once a test is green, we don't allow it to go back to red. Still, upgrading has been historically hard for us. Sometimes, for a reason, it actually pains me to show the next slide in this way, because of metaprogramming. Once upon a time, the Rails community was way much more metaprogramming happy than it is nowadays. I love this book, by the way, I have it signed, but that's a bit the reality. What we found is that the more metaprogramming that there was, the more monkey patches, the more unstable and hard to maintain the code was. It was pure hell. Like if you are monkey patching something and somehow you created basically a fork of the original code, with the time is unmaintainable. But said this, we kept doing a lot of monkey patching until Rails 4. At Rails 5, things become too hard. Basically, trying to upgrade to Rails 5 broke all the tests. So at this point, we decided to go hard mode. Remove as much monkey patching, remove as many forks as possible, and go back to the source of everything. That upgrade took a long time. It took 2.5 years with a dedicated team. Here you have an evolution of the last 9 months of it, with first focusing on the failures and then going for the errors. And what were the main issues that we found there? Again, we monkey patching and forking existing things. We had our own version of strong parameters. We started using strong parameters, I don't know, Rails 2 or Rails 3. Strong parameters was added to Rails in 4.2, I think, when we found out that the version that Rails merged was very different from our fork of stronger params. So we had to go back. The other, actually, this one was kind of a big issue in the Rails community at that point, was in Rails 5.2, the Rails core team changed completely how dirty attributes work. Before, user.change returned true in certain cases, and then after 5.2, started returning false. Zendesk, we had a lot of hooks that depended on change. And the problem with this was not so much that it was hard to understand what was happening, but it was like shared across all code. So completely different business units had the same problem, and they needed to find a way to go around it. Only that added 6 months to the upgrade. Also because we had to communicate with a lot of different teams for them to execute the change. The good news is that since then, it has been way easier to keep in the current version. My lesson out of this is that we always had kind of a first mover disadvantage. As I commented before, we started using strong parameters early. We used other things, like for example sharding. We started using sharding in, I think, Rails 2, maybe earlier than that, with a gem. Of course, when Rails 6 added sharding to main, it was great, but at the same time say, well, now we need to go back and change all our sharding to use the same way as Rails does. My advice after 10 years at Zendesk would be, don't go solo. Go with a group. Join the community. If there is a gem or a library that's already doing this, and even if you think it's broken and it doesn't work, just try to help there and bring it to the point where you want it to be. Even better, try to talk with the Rails core team. Try to put features and add to the big community. Okay, we're finishing, and I would like to leave you a bit with some ideas. Also, the reason why I wanted to talk about this. A couple of years ago, Anatoly and me did a presentation called a Rails Performance Guidebook, and it was a lot focused on scaling, but about scaling performance. One thing I realized is that performance in the end is very important, but typically companies, startups don't break because of performance. There's multiple reasons for that. First of all, a company that doesn't scale tech-wise is kind of obvious. You see very clearly the problem. If you build an engineering organization that doesn't scale, it's a problem. It's like a bomb. It's going to explode at some point, but it's going to mess you up in a lot of different ways. Moreover, what constitutes a well-run organization is quite debatable. Like, we have a lot of very different models of how our organization should run, and it's not obvious which ones are good and which ones are bad. My take was that you can learn a lot from people that had experience before you, because past can make you powerful. You know, sometimes when you're in a situation that you've seen before, and you're with a team of people that has not seen it, you feel a bit like Gandalf, no? This kind of old creature, powerful, wise. Still, there's another side. Past can mess you up. The other day I was talking with a team that they told me that doing things in a certain way was impossible. And I thought, why? Eventually it was because 3 years before they had failed. And I told them, well, 1 year ago, this other team in a different location succeeded, and actually you can just do exactly the same as they did. The past can corrupt you in a way, can make you believe that certain things are impossible, or that there are only one way of doing things. We'd like to go back to the idea of the book of Gospodinov, where the people, like the people of Europe, decides voluntarily to stop the future and go back to the 1970s, the 1980s, and live forever in the jail of their memory. What is my solution? Well, you need to listen to the past, like listen to stories. Not put your personal opinions on it, not put your self-esteem on it. Just listen and try to learn as much as possible. Maybe like this, you can merge the past with the future and become of some kind of illuminated Ruby and help illuminated Ruby engineer and help the community. Thank you.